On va enchaîner immédiatement avec la prochaine conférence qui sera la dernière de la session. Le conférencier devait être M. Jim Coppard, Regional Head of Exploration Arctic pour Anglo-American. Heureusement pour lui, malheureusement pour nous, M. Coppard a dû se rendre à Stockholm aujourd'hui où on lui a décerné le Nordic Exploration Award. C'est seulement la 5e fois que ce prix est décerné. Alors ça montre toute l'importance de la découverte qu'ils ont faite à Sakatti. Et je le félicite d'emblée. Et heureusement pour nous, un collègue, M. Christian Innenfeld, a décidé de faire la conférence. Christian is a senior geochemist with Anglo-American Exploration. He holds an MSc degree in geology and a PhD in geochemistry. Christian joined Anglo-American in early 2007 and since then has worked on a number of porphyry, copper, nickel sulfide, PG, and VMS projects around the world, including the Sakatti project presented here today. His role as regional geochemist for the Arctic has recently been expanded, and Christian now also acts as global coordinator of the geochemistry discipline in Anglo-American exploration. His roles prior to Anglo-American include 3 years as research fellow at Monash University in Melbourne, Australia, where he worked on magmatic nickel sulfide and PGE deposit. Aujourd'hui, sa conférence a pour titre The Sakatti Discovery. Christian?
Thank you, Paul. And as you heard, I'm giving this presentation on behalf of Jim Coppard today. We all know discoveries and exploration is very much a team effort, but I think Jim is really the man behind this discovery. And as you'll hear, Sakatti is a great and a rare example of a true greenfields nickel sulfide discovery. I'd also like to point out my colleague Stephanie Klatt. She is the senior project geologist on site and has been looking after the technical side of the project for the last 4 years. So Jim and Stephanie actually put the presentation together, and I hope I can do justice. Just briefly, this is our standard disclaimer. Sakatti is located in northern Finland. It's actually about 150 kilometers north of the Arctic Circle, but quite different to similar latitudes here in northern Canada. It's actually in an area of excellent infrastructure. It's right beside a main north-south highway, and the nearest existing railheads are only about 130, 110 kilometers away. The county town of Sodankylä is just about 25 kilometers to the south, with a population of about 8,000 people. So there's excellent infrastructure. And you may know First Quantum's Kevitsa mine, which is just another 20 kilometers northeast of Sakatti. Just a little summary of the discovery history. Work on the project work in the area started in 2004. And what had drawn Jim into the area was, one of the key reasons was the similarities he'd seen between the Pechenga-Imandra Sugar Belt, which obviously hosts the world-class Pechenga nickel camp, and the Central Lapland Greenstone Belt, which where he'd worked before exploring for diamonds with a different company. So he had that knowledge of the area, and he saw the similarities, and that's what drew him into this area. And obviously the Kevitsa deposit had been discovered by the Finnish Geological Survey in the late 80s. So there was already indication that there might be potential in the area. Also very helpful was the excellent base geological and geophysical data sets from the Finnish Geological Survey. And in fact, all the initial targeting had been done using these publicly available data sets. And actually this initial targeting already highlighted Sakatti as one of the high priority targets. So it was ranked as target number 8 at the time. Following this initial target and kind of, there was infill airborne geophysics, ground geophysics, and base of till geochemistry being done. And this together then led to the discovery of the subcropping zone of the ore body. And I think it's important to point out that this is very much conventional exploration methods which had led to the discovery in an area that was considered by many as mature. First drill testing of the Sakatti target was in 2006, and then after a brief hiatus, the discovery hole was drilled in 2009. That was hole number 13. And our team has also discovered a number of other mineralized intrusions within the area, so there's clearly camp potential. And obviously what's important for a company like Anglo American is already when you start off that you explore in a responsive and sustainable manner. Just showing here, pointing out that analogy between the Pechenga Imandra Vasuga belt here on the Kola Peninsula and the central Lapland Greenstone belt here in Sakatti is in this area. This is the north of Finland. And just for comparison, the stratigraphies of the two belts, and Sakatti sits in here what's called the Matarakovsky Formation, which is equivalent to the Pechenga Sedimentary Formation and the productive horizon at Pechenga. So, as I said, Sakatti is a significant greenfields copper, nickel, PGE, gold, and also cobalt discovery, and it confirms the potential of the area. To date, we're still pretty much in a state of delineating the ore body, and we've drilled about 65,000 meters to date. Until last year, all the drilling was done in winter because the deposit actually sits in a bog. And we've also been using for the last few years a closed system drilling technology to minimize our footprint. We've drilled so far massive, semi-massive, vein type and disseminated style sulfide mineralization. And apart from the subcropping area, the deposit is blind. And it's also interesting to point out that conventional EM systems actually can't see the deposit. It's only the Anglo in-house low-temperature squid which actually picks up the deposit and the main part of the deposit from the surface. There's a couple of satellite bodies related to Sakatti which are actually picked up in VTEM surveys. The surface expression of the mineralization at depth has a current extent of 1.5 kilometers by 700 meters, and the body plunges from the eastern part where it subcrops under several meters of till cover as a coherent mineralized body at an angle of about 45 degrees to the northwest. At this stage, the deposit is still open to the west, to the north, to the south, and also in many parts at depth. In parallel with the drill out of the Sakatti project, we also run a regional exploration program, and in fact we hold it's 100% tenure of 830 kilometers, square kilometers in the area. So there's still a lot of potential. Just talking a little bit about the geology, most of the mineralization is hosted within a serpentinized ultramafic body, predominantly peridotite, and so the deposit is clearly magmatic in origin. The peridotite is overlain, and I'll show you some sections, is overlain by quite a thick packet of a quite enigmatic breccia. It's quite heterogeneous and polymicted, and the sidewall and in many places the footwall contact is with an aphanitic mafic unit. As I said, we've intersected many different styles of mineralization. We'll see this later on. And in many parts, there's also evidence of hydrothermal alteration of the silicate portions and also the mineralization. This here, a north-south section from the middle part of the deposit, and just highlighting some of the key rock types. What's highlighted here in red is that's the main peridotite body, which hosts most of the mineralization. And it very much reminds me what Peter Lightfoot was showing earlier, one of these snake-like conelytic bodies. It's primarily an olivine cumulate, in some places olivine pyroxene cumulate. It's pervasively serpentinized, but still preserves all the magmatic textures. We can't see any systematic layering within the peridotite, but there's clear evidence for multiple pulses of intrusions. And the textures range from adcumulate to orthocumulate. And so now moving to the aphanitic volcanic. It has quite a distinct texture. It's a fine-grained andesite plagioclase rock, also contains some olivine, and it generally sits here forming this sidewall and footwall contact. And closer to the contact, you also find mineralization within this aphanitic unit, but this is primarily fracture and vein-controlled mineralization, clearly injected from within the peridotite body. And these photos are some examples. This is actually photos taken very close to the contact with the peridotite, and the dark parts you see here is actually where the peridotite injects into this aphanitic unit along this pre-existing texture within the rock. And then in the hanging wall, this thick package up to 200 meters thick of this enigmatic breccia. We still don't know the origin of it. And then also usually some tophitic mafic units sitting in the hanging wall, but also between the breccia and the aphanitic, and also in the footwall, often more massive. Just some examples of the mineralization we've encountered so far. So starting here, this is the typical disseminated chalcopyrite mineralization, very fine-grained. These are examples of massive sulfides. This is very rich in chalcopyrite here. And this blebby-sulfide mineralization, something what we call the breccia-type semi-massive mineralization. And this is the massive chalcopyrite peridotite pentlandite mineralization. From just talking a little bit about the PGM mineralogy, because as we'll see, PGE is a significant byproduct. So from med test work we've done through Autotech in Finland, and also through a PhD study sponsored by Anglo American, it's pretty much predominantly tellurides. And from a recovery and metallurgical point of view, the good news is all the PGE minerals are very closely associated with the sulfides, and none are actually found within the silicates. So we actually can expect very good recoveries. This is a plan view showing the surface expression of the mineralization we've encountered so far. These are all the drill holes. Until now, we've drilled pretty much still in 100-meter intervals. In some areas, we've already started with some infill drilling. Most of the drilling had been to the south. What's also pointed out here is two satellite bodies. The connection is still, we're not really sure how they're connected to the main body. This is the southwest, and this is the northeast zone. Northeast is particularly interesting. We've already drilled quite thick, massive sulfide lenses at relatively shallow depth, and also the disseminated mineralization. So that northeast part is definitely also an interesting target. This is the same area, looking at the mag, reduced to pole mag, and also interesting to see it's only the shallow part here of the deposit where it actually subcrops, where you get a high mag response. Here in the lower part, you actually don't. So it doesn't really have, the lower part, an obvious geophysical signature. I'll be showing you two examples of intercepts, what we've encountered along profiles along here and here. And it shows also how the mineralization changes within the ore body. So we start off with predominantly disseminated mineralization, chalcopyrite dominated, often pure chalcopyrite here in the shallow part. And as we get deeper, you get more and more vein type mineralization as well. Still very much copper vein type mineralization as well. Still very much copper dominated, chalcopyrite dominated. And as we go deeper, we also get the massive sulfide and more nickel. So the first section along here, I'll show you the intercepts will be from the south to the north. You can see here most of the holes drilled to the south. Again, here, this is the peridotite body, and here the aphanitic unit. Just showing here the distribution of grades. Here, these are the bars, PGs. What's shown here in blue is copper and nickel grades. And just a summary of how the intercepts, which I'm going to show you now, were calculated. So it's a JORC-compliant calculation. I don't want to go into much detail here. And here, said going from the south to the north, I think I don't need to point out too much. The intercepts and grades actually speak for themselves. Just pointing out hole number 13, this was the initial discovery or the official discovery drill hole. So we have here 100 meter at 1.4 copper, 0.3 nickel, as I said, in this part of the ore body, not very much nickel, and quite significant PG and gold grades. And already some shorter intervals of quite significant mineralization here. So this is still the same section, and we go further to the north, and pretty much still the same type of mineralization and very similar grades and intercepts. So now as we go further to the west, show you this section here. So this is now the part where we get more into the massive sulfides, and also getting much higher nickel grades in this part. Here again, the peridotite body here, somewhat wider than in the previous section I showed you. What's pointed out here in red, this is a massive sulfide lens, and you can see here how it cross-cuts the contact between the peridotite into the aphanitic. Again, the grades. And here the intercepts. So just highlighting some of these. So we get 50 meters at 3%, 3.13% copper. Still here in the southern part, we're very much in the aphanitic, where it's the injected mineralization. We have relatively low nickel grades. And as we go closer actually into the peridotite, or closer to the contact with the peridotite, the nickel grades get also higher. So we have here, these are some of our best intersections so far in the main body. We have almost 25 meters at 3% copper, 3% nickel, and almost 1 gram per ton platinum palladium. Very similar here, and also here. So as I said, we're still very much at the stage of delineating the ore body. It's still open. We're still, in most parts, actually drilling at 100-meter drill spacing. We're currently working at an initial resource number, so it would be an inferred resource. So that should be completed by early next year. And just also pointing out, you heard before, Jim was awarded the Nordic Exploration Award earlier today in Stockholm. Last year, when actually Anglo-American for the first time presented results on Sakatti, Jim had received the 5th Fennoscandian Mining Award, and it was actually awarded to the exploration team as a whole, led by Jim. And apart from the technical side, obviously, as you all know, community engagement and engagement with the local stakeholders, in this case, the local reindeer herders, is a crucial part of getting this project forward. So in summary, Sakatti is a significant grassroots discovery. It is actually a rare example of a nickel discovery which went from an initial exploration concept to the final discovery, unlike Voisey's Bay, which was more found by serendipity. And I think we want to point out also that the Anglo-American exploration team worldwide over the last 10, 15 years has had a very good track record with a number of significant discoveries worldwide. And pointing out, so key people involved in the initial targeting were definitely Brian Williams, the geophysicist, and Dennis Fitzpatrick. I think credit definitely goes to those two. And then the entire team, some examples here, who worked very hard and very long hours on site actually drilling out the deposit. A number of consultants, and what's always very important to actually have the high-level support for the project. You've seen it went on from initial stage in 2004, so we're now 8 years later, and you need that continuous support from senior management. So some of the lessons learned. I think you very much have to let the rocks talk for themselves. You shouldn't be too fixated by models, and that was definitely one of the lessons which had been learned. Jim also believes very much in the hunting pack teams, so keeping multidisciplinary teams together working on the project. The continuous support and the belief from senior management, and okay, nothing can beat the boots on the ground. You actually need to be there. Persistence and the flexibility that you can actually pick up tenure, as in our case, the 830 square kilometers, when it becomes available. When the prospective ground becomes available, you have to act. And the continuous review of what you're doing and of the data is, I think, very important. Okay, thank you very much.
Merci beaucoup, Christian. On a définitivement le temps pour des questions. Merci beaucoup, Christian. Alors, ça met fin au volet des conférences. Je vous invite à demeurer dans la salle puisqu'il va y avoir remise de prix, particulièrement la médaille Nicolas Denis, le prix Hector Routier et le prix développeur autochtone. Je pense que c'est Jean-Marc qui va